Welcome to a new episode.
Hello, you're listening to the Copper Connection podcast, the show that helps students, apprentices and future tradespeople build solid careers one episode at a time. As always, I'm your host, Chris Bailey. Today we're going to walk through something that every plumber, heating engineer or construction professional is a part of, even if you don't always see it. We're talking about the design process. From the first idea on a bit of paper all the way through to the completed building that people live, work and relax in. If you've ever turned up on site looking at a set of drawings and thought, how on earth did we get from this muddy field to that finished plan? This episode is for you. We'll be breaking it down step by step, keep it real and link it back to the kind of work you'll be doing on site. So let's start before anyone even steps foot on site. Imagine this. You have been taken on as an apprentice with a small plumbing firm. Your boss gets a new job on a new build estate. You rock up on day one expecting to run pipework, and the site is chaos. No one knows where the materials are being stored, the welfare unit isn't set up, there's no clear order of works. Electricians and plumbers are trying to work in the same space, deliveries are turning up at random times. You're standing there thinking, this is a nightmare. Most of the time when the project feels like that, the problem started long before you arrived. It started with poor planning. There's a classic saying in construction, so I will give you the clean one. It's proper planning and preparation prevents poor performance. That's the 6 Ps. They're not just a cheesy slogan. They're how you hit deadlines, stay within budget and keep your client happy. Before work begins, someone has a plan. The programme of works, what happens first, second and third. The method statements and risk assessments, how to do tasks safely and correctly. Site layout, where materials, waste and welfare go. And then suppliers and subcontractors, who's doing what and when. Plant hire, what's needed to be on site, ready to go. As a student apprentice, you might not be writing these documents yet, but you need to understand that your job fits into the bigger plan. Will make you sharper on site and much more valuable to your employer. So, before designers can draw up a single realistic plan, there's critical steps. This is site analysis. Think about site analysis like a doctor's first checkup before any treatment. You don't write a prescription until you know what's going on. On a proposed site, we need to understand the following. The site's how big the plot is and will it fit? Location, is it in a city, rural area, near a busy road? Topography, that's just a fancy word for the shape of the land. Levels, slopes and uneven ground. Existing features, buildings, trees, walls, surfaces are already in place. Here's why this matters to you in the building services trades. If the land slopes, that affects drainage runs, manhole positions and pipe gradients. If there are existing trees, roots might restrict where you can dig or lay services. If areas are tight, deliveries of boilers, cylinders or pipe bundles need carefully planning. A good designer looks at this before putting any lines on a drawing. When you arrive as an apprentice, the quality of that early thinking is what makes your job smoother or even harder. Before a building can legally go ahead, we need to know, are we allowed to build this here in this way? There are 2 main stages you'll hear about. First is the outline planning permission. This is like asking the council, in principle, is it okay to put this type of building here? The application might include a basic description of the project, simple drawings showing position, size and use. If the local authority says yes in principle, then you can move on to the second part, which is full planning permission. This is where all the detail comes in, floor plans and drawings, supporting documents, application forms and most importantly, the fee. Think of the outline planning as checking if you're allowed to sit an exam. Full planning is like submitting all your coursework and evidence. There are mandatory national planning documents that almost every application needs, like A planning application form. This can be on paper or online. Ownership and agricultural land certificates confirms who owns the land and how it's being used. A site location plan, usually at a ratio of 1 to 1,250 or 1 to 2,500 scale, with the site outlined in red. A site block plan, showing boundaries near buildings and trees. A design and assessment statement, a short report explaining the design and how people will access the building. SUDS proposals for major applications, that's sustainable drainage systems. And of course, as always, the planning application fee. On top of that, local planning authorities may ask for extra documents like affordable housing statement, surveys for contamination, ecological levels, utilities and trees, assessments for sustainability, transport, daylight, flood risk, or even noise. You might not be the one submitting these, but if you end up running jobs or starting your own business in the future, this is the process you'll likely be stepping into. Now, not every change to a building needs full permission. In the UK, we have permitted development rights. These allows homeowners to make certain small changes without going through the full planning process. This might include small extensions, garages or outbuildings, loft conversions, or roof space conversions, converting an existing garage. But, and there's always a but, permitted development. This can vary between local authorities, usually doesn't apply in conservation areas or national parks, has limits on size, heights and placements. Before 2008, only around 20 square metres of new floor space was allowed without planning permission. The rules later changed, allowing more types of extensions and conversions. So if you're an apprenticeship and your customer says, oh, we don't need planning for that, it's fine. It's always worth them checking with the local council or professional first, because doing work without the correct permissions can lead to serious trouble. There are also specific planning consents. Listing building consent needed before altering a listed building's appearance. Conservation area consent planning checks. This is needed for demolishing buildings in these areas without permissions is a criminal offence. And tree consent. Some trees are protected by tree preservation orders, even outside of conservation areas. Then there's retrospective planning permission. That's when someone has already built or altered something without permission and then tries to get it approved after the fact. If the council refuses and issues an enforcement notice, they can force you to remove or alter the work, prosecute for non-compliance, or issue fines up to the value of £20,000. So for your future career, never assume it will be fine. Encourage clients or employers to check planning requirements, understanding that legal or non-compliant work can come back to bite you later. So what happens if planning application is refused? There are three main ways to appeal. First, we have written representation. The simple and cheapest. Best for smaller projects like extensions or change of use. An independent planning inspector reviews the paperwork. Then we have step 2, which is the hearings. Everyone's involved meeting with the independent inspector. Good for more complex cases when arguments need to be discussed. And then number 3, public inquiry. Used for large or controversial developments, often when there are big environmental impacts or lots of public opposition. Now, ideally, we want to be avoiding getting to that stage. That's where feasibility studies come in. A feasibility study is done early to ask the following. Will the project meet the client's need? What barriers or problems might there be? Is there enough demand for it? Will it actually make money? Skipping feasibility is like taking on a massive job without checking your tools, your skills, or your timing. It might work, but you're taking a massive risk. As a future tradesperson, understanding feasibility helps you spot red flags. This drainage run seems unrealistic. Have we checked where existing services are? Is there access for future maintenance? Those questions make you look like a professional, not just a pair of hands. Here's a part of the design process that often surprises students: wildlife and the environment. Before building starts, a wildlife assessment check may be carried out. This looks at plants and animals, habitats on or around the site, how the development and its access roads, services and drainage will affect them. Development can put pressure on habitats, some of which are home to protected or vulnerable species. Then there's Japanese knotweed. If you've never heard of it, remember it, because it can cause major headaches. Japanese knotweed is an invasive plant species capable of damaging buildings and hard surfaces. A legal issue under the Wildlife and Countryside Act 1981 means you must declare it if found on site. So if found on site, a strict management plan is needed. It can affect planning permissions and it can devalue property and make it very hard to sell. So if you're on site and someone mentions knotweed, that's not just a gardening problem, it's a legal and financial issue. There are also sites of special scientific interest, or SSSIs. These are areas protected because of special geological or rare species. They may include grasslands and heathlands, woodlands and wetlands, lakes, cliffs and cultural stretches. Working in an SSSI usually needs special permissions. Ignore them rules can mean heavy fines, paying for expensive remedial works. An example is Winnett's Pass in Derbyshire, a limestone valley full of fossils. There, you're not allowed to remove rocks or plants because of its scientific importance. So again, when you're a part of a project, the bigger picture isn't about bricks, pipes and cables. It's about the environment your worksite sits in and the laws that protect it. So now let's talk about utilities and services, the heart of building services trades. Every modern dwelling needs water, gas or electric for heating and power, waste and sewage removal, telecoms, especially broadband in these days. These can't just be add-ons later. They need to be planned at the design stage. Where do pipes, cables and ducts run? How will they be accessed for maintenance? Is there capacity for future expansion with extra bathrooms, EV charges and renewables? A good design means that services are efficient, safe and coordinated, so trades aren't constantly clashing or redoing others' work. On the technical side, we're dealing with networks, water and sewer systems, gas supply with safety features, electronic transmission and distribution, and fibre optic telecoms. Looking ahead, buildings of the future will push this even further. We've already seen more renewable energies with solar, heat pumps, low-carbon systems. We've got low-carbon materials like timber, blended cement, rammed earth walls, and smarter homes controlling heating, lighting, security, and communications. Designs that minimise carbon footprint with smart installation and building orientation. For the plumbers or building services students, this is exciting. It means growing demand for people who understand energy efficiency, can install and maintain modern systems, can read and follow technical smart designs. Your skills will be central to making future homes possible. As we get closer to work starting on site, the design moves into detailed planning and scheduling. First, there are terms like frontage line and building line. The frontage line is the line that matches the public frontage, basically where the plot meets the street or public area. It defines the minimum plot width. The building line is usually set back from the frontage line. It's where the building is actually allowed to sit. These positions are shown on working drawings and they can affect how close you can build to the road, where you can run services or access for maintenance and future upgrade. Then there's the question, who does what and when? That's where a Gantt chart comes in. A Gantt chart lists all the tasks on a vertical axis, shows the time across the horizontal axis, so hours, days, weeks, months, plots when every task should start and finish, often including labour plan and equipment needs. So you might see groundwork starting in week 1, foundations work in week 2, and drainage in week 3. First fix plumbing and electrics around about week 12. As work progresses, the actual times are recorded. If something overruns, the team can see what other tasks it delays and what needs to be rescheduled. That ties into the critical path analysis, or CPA. CPA works out which tasks must happen in a fixed sequence, which tasks can happen at the same time, which tasks, if delayed, will delay the whole project. For example, you can't do a second fix plumbing before the walls are up and plastered, but you can sometimes run certain services in parallel, as long as there's space and safety allows it. When you're an apprentice, understanding Gantt charts and the critical path helps you see why your supervisor is pushing to hit certain dates, understanding why one delay can snowball into a bigger problem, and plan your own workload and learning. This is the difference between just showing up for a day's graft and actually think like a future site supervisor or business owner. Okay, so let's pull this all together. The design process from conception to completion isn't just some distant office-based thing that doesn't involve you. It's the reason there's a clear plan before you arrive on site, the reason buildings are safe, legal and environmentally responsible, the reason your work as a plumber, heating engineer or construction professional actually fits into the bigger picture. So today we've talked about the importance of proper planning and the 6 Ps, site analysis and how the land shapes the design, planning permissions, permitted development and what happens if you ignore the rules, feasibility studies, wildlife checks, knotweed, SSSIs, utilities and services, and how future homes rely on smart building services. And finally, how Gantt charts and critical paths keep projects on track. If you're a student or apprentice right now, here's your action step. Next time you're on site, look beyond today's task. Ask, where are we in the overall programme? What had to happen before we got here? What depends on the work I'm doing today? Those questions will help you learn faster, stand out as someone who really understands the trade. If you found this episode helpful and you want more straight talking guidance on plumbing, construction and building a career in the trades, make sure you follow and subscribe to the Apprenticeship podcast. Share it with a mate on your course, an apprentice on site, or anyone thinking about future in the trades. I'm Chris Bailey, thanks for listening, and I will catch you on the next episode of the Copper Connection podcast.
We'll be back next week. In the meantime, please subscribe and thanks for listening.